Can you hear me? Okay, perfect. Hey everyone, it's so wonderful to be here. My name is Marek Olszewski, and I'm one of the co-founders of Celo. And today we're going to be talking about building an L2 with EigenDA and a decentralized sequencer. I've challenged myself this year to try to give talks solely using emojis, or at least mostly using emojis. So if you like the format, let me know either afterwards or on Twitter. And yeah, I guess, all of this is in the context of something that we announced earlier this week, which is kind of this proposal to turn Celo into an L2. Just kind of curious, maybe show of hands, who here heard about the proposal earlier this week? Cool. Okay, so that makes me happy because you guys have the context, and I'm glad you guys actually did raise your hand. Otherwise, this slide would have been awkward. And yeah, this is emoji number 1. Hopefully you guys maybe checked out the forum and took a quick peek. Today we're going to be talking in a lot more detail about how the proposal works, and also some of the challenges and some of the thinking behind some of the design choices we made. So, but before we begin, I just wanted to give like a 30-second overview of Celo, just so we're on the same page. So today, pre-proposal, Celo is an EVM compatible proof of stake layer 1. And it's EVM compatible because when we launched it, or we started working on it 3 years ago, it was really after we tried building really easy to use mobile applications on Celo on top of Ethereum. And when we couldn't quite create something that was easy enough to use for everyone, that took us down the path of launching or building out a scalable kind of EVM compatible, of course, proof of stake network. And a few interesting things happened after that. Literally, the network was launched 3 years ago by a quorum of community validators, and literally within the first week, someone proposed making Celo a carbon negative chain. So having the Celo offset the carbon that it was contributing to. This was 3 years ago, way before Ethereum did its merge while it was still proof of work. Folks really wanted to put a stake in the ground and show that blockchains could be actually good for the environment. And so since then, it's been programmatically buying carbon offsets, which is really cool. And starting with the next hard fork next month, it's also going to be using a portion of base fees to buy carbon offset credits as well. So people, really think of Celo as a really green chain. A lot of refi is happening on Celo. But it's also a mobile chain, right? That was the impetus initially for its existence. We tried building a global Venmo wallet on top of Ethereum. We couldn't make it easy enough to use, and so we wanted to build something that had the features that allowed you to build really easy-to-use mobile applications. So we have this protocol called Social Connect, which lets you send value to phone numbers across wallets on the chain, even before the recipient actually creates a wallet. And so this is just one of the many mobile features. Another really nice one is a ZK Snark-based client that lets you sync with just a few kilobytes of data. Because of this mobile focus and just this origin, where we wanted to create a platform that allowed you to build these really easy-to-use mobile wallets, a lot of thought went into making Celo just really a good place to build really easy-to-use end-user applications. And one of these, I would say, features is this ability to pay for gas with tokens on Celo. So even pre-account abstraction, this is fully native. Even with EOA accounts, you can pay for gas with tokens, which means that if you send the stablecoin to someone, you can pay for that transaction fee in the stablecoin. They can send it on to someone else. You're never going to be stuck with this situation where you're like, oh shit, I have some USDC and I can't move it. I don't know who here has had that happen to them. Yeah, I mean, me too, right? It's pretty much all of us. It's very, very frustrating. And normies, it's one thing for us. It's another thing for normies to have to deal with that. So that's, Celo in a nutshell. But we're here to talk about kind of the future of Celo, which is kind of this L2 proposal. And so, what does that look like? As I mentioned before, when we were thinking about this proposal, we were thinking about it in the context of the existing users that we have today, the existing network that is running today, which ultimately creates some constraints and some challenges for us as we kind of thought about this design. And so what are those challenges? What are those constraints? I would say there's two really big ones. The first of which is that gas fees are very low on Celo. This is kind of by design. We worked hard to create I would say, a really nice scalable consensus protocol, proof of stake consensus protocol that uses a lot of the same cryptography as ETH2, but we launched it 3 years ago, so 2 years roughly before the merge. And this has resulted in this and the ability to pay for gas with tokens and the mobile focus, has just resulted in a lot of use cases that are more targeted to real-world use cases where people are, for example, doing P2P transactions between mobile phones, payment use cases, microfinance use cases. If anyone here has used Kiva before, there's a protocol that's very Kiva-like, but Web3 native on Celo. There's folks who built applications that allow you to earn crypto for micro tasks on your phone. So a lot of these types of use cases that really require transaction fees that are, I would say, sub 1 cent, right? I think the 20 cent, even 50 cent transaction fees that you sometimes have to pay on, some of the L2s today because folks are doing data availability using the Ethereum main chain. That wasn't going to work for these users, and we didn't want to create something that would, basically make some of these applications obsolete. So that's the first constraint. And so what's the solution? Well, again, for those who saw the proposal and looked at it closely, it's really EigenLayer. We're really thrilled that EigenLayer launched recently because we were searching for a solution for this for a while, and we didn't want to do something where you just use a very small permissioned committee of trusted folks. It just didn't sit right. It didn't feel decentralized enough. And luckily, EigenLayer. How many people here are familiar with EigenLayer? Just so I can give enough context. Most people here are familiar. So as you know, it's effectively a marketplace for trust in the Ethereum ecosystem, and so. It lets folks restake their ETH that they're staking for running a validator in Ethereum. And it allows them to use that stake to offer additional services, in effect selling their trust to others, not just to the broader Ethereum chain for securing the chain, but potentially other things. And as we all know, Ethereum is highly decentralized, and so that's a lot of trust, right? That's a really great place to look for a very decentralized data availability protocol. And what's really amazing is that it's not only are there a lot of people who can opt into this, they also don't have to pay anything new because they've already staked once. And so the barrier for them to adopt EigenLayer and all the middlewares that will soon pop up is much lower. And so that's really great. And of course, the middleware that we're particularly excited about is EigenDA, which is a middleware that brings effectively a dank sharding-alike protocol to the Ethereum ecosystem. Potentially, 1, 2, who knows how many years before dank sharding ends up being released. So that's really exciting. And so we're certainly. So the proposal talks a lot about kind of using EigenDA, and we're going to go into exactly how that looks like in a sec. But before we do that, there's challenge number 2, which is that Celo is already a decentralized layer 1, right? We have a lot of node operators that are participating in the network, that are validating the network, that are running the consensus protocol, the proof of stake consensus protocol, and it would be a real shame if we kind of just collapse that to just one machine, right? It took a lot of effort, I would say, to kind of build kind of this community of really great folks. We have some amazing solo validators. We also have some incredible professional validator shops. as well as big corporates, right? Deutsche Telekom is excited about kind of the mobile kind of direction of Celo, and so they actually very early on chose to kind of join the ecosystem, and they've been participating in validation ever since. And there's many other really great corporates as well that are participating. And so it would just be sad if they all had to shut down and kind of move on. And so we wanted to find something that would not only keep them, but also I think benefit from the decentralization that they offer. And so that's the reason for us really focusing on finding a path to turn this validator set into a decentralized sequencer set. And that's exciting because, as you know, decentralized sequencing is relatively new. Most of, especially the big networks, are still relying on centralized sequencers, and some haven't even started actually designing and building out their decentralized sequencers. And so we're excited actually to take the work that we've done. Celo's proof of stake consensus protocol has been live now for over 3 years. It's been rock solid. It's only had one production incident, and so it's also like a really great foundation for a decentralized sequencer. And it's one that we hope to contribute kind of to the broader community through kind of a module that can be plugged into, say, the OP stack. Now, challenge number 3, and those of you who have been listening closely will say, wait, you said 2 challenges only. And that's because life is never that simple. You always think it's only 2 or 3 or 4, and then suddenly you realize, oh, actually there's way more things we have to think about. And for us, that kind of unexpected thing was one-block finality. Because of the ease of use, because of the mobile focus, and because of the focus on kind of real-world use cases, Celo has had a design from the beginning that offers one-block finality. And this is just something that's hard to implement in something that is rolling up to a chain that doesn't have one-block finality. And it's important. I talked about how we don't want to kind of change fees for our users. I think we also don't want to change kind of their expectation of finality either. And quite frankly, one-block finality is quite useful. Certainly, if you're making a payment for something and you're getting a physical item in exchange, it's very difficult to recover from that kind of 2-person transaction if suddenly the payment gets reverted, right? The person has already the item, you can't revert the item. And so we spent a lot of time looking at the solution here, and I think the most obvious solution is to add slashing for equivocation. So we'll see this in a sec in a detailed diagram, but in effect, when a chain, to prevent reorgs, you want to make it basically very expensive to in this case, the decentralized sequencers, in the current case of Celo, the validators, to equivocate on a certain block or on a certain transaction bundle. If they do that, then they'll get slashed. And it's not just one, but actually, as we'll see, it'll end up being up to 2/3 of these folks who can get slashed. And so there you add some economic security. And then the other thing you have to do is, some of the existing L2 designs, when you're depositing from the L1 to the L2, you don't always have to wait for finality on the L1. And that's because the L2 is happy to reorg if the L1 ever reorgs. And so if, say, your transaction gets reverted on the L1, that's fine, it'll get reverted on the L2. And that's nice because it gives you kind of a shorter bridge latency when you're going from the L1 to the L2. But it does mean that if the L1 reorgs, the L2 will have to reorg. And so if we want to prevent the L2 from having to reorg in these cases, then we have to make it so that deposits and also forced transactions really can only be considered finalized at the L2 level after kind of the Ethereum finality window, so roughly 8 minutes or so. And so that's the other kind of change that we have to make. So how does everything look like together? I kind of have this little build that kind of goes through the life cycle of a block. So hopefully this will kind of illustrate a little bit how this looks like. We have kind of the three main roles in the L2, the decentralized sequencers, the EigenDA nodes, and the L2 full nodes, and then kind of the Ethereum chain I'm just showing below. Step one is the decentralized sequencer is running a BFT-based consensus. BFT typically elects a leader, and then that leader has some time window to perform some actions, and those actions include starting off by proposing a transaction bundle, and so that's what this leader here, I don't know if you can see that clearly, it's kind of glowing blue to denote kind of the node that's kind of taking the action at this time step. And so it proposes a transaction bundle, broadcasts it out to the network, to all the other validators. Sorry, validators today, sequencers tomorrow. And those sequencers look at the transaction bundle. In an L2, they don't have to execute it, so it's actually quite easy. They can achieve consensus relatively easily. And they do so by sending their signatures back to the leader. On Celo, we use BLS cryptography, BLS 12377 cryptography, which allows you to aggregate all of these signatures into a single multisig, similar to Ethereum. So this is nice, it's small, constant size, but because we need the ability to, we need attribution, we also include a bit vector of everyone who signed. And so now we have kind of the transaction bundle, we have a BLS multi-signature from the kind of BFT consensus and that bit vector. And now, technically any node that's sequencing can do this, but for simplicity, we think it's best to have the leader do this, and if the leader fails to do this, someone else to jump in. We send kind of the combination of these two things to EigenDA, which will effectively kind of shard this data across all the different EigenDA nodes and return a threshold signature, which we can call an EigenDA certificate, and that's over the hash of the data. And one of the really nice things that EigenDA offers is that, because you can effectively shard this across the entire EigenDA kind of validator set, if you want to call it that, it's actually very, very cheap from a cost perspective. And so this is kind of one of the reasons why we're very excited about EigenDA and about dank sharding. In distributed systems, data availability is actually not too difficult of a problem. It's one that parallelizes quite nicely. Consensus is one that doesn't parallelize quite nicely. And so that's the expensive one. And so that's why today, for many rollups that are using Ethereum for data availability, they're paying kind of 90% of that transaction fee that you're paying to the L2 is actually going primarily to cover data availability on the L2. And so if you use something like EigenDA, you can actually lower that. And in the future, if you use dank sharding, you can lower that significantly, which is really nice because then it allows you to keep transaction fees cheap. And so you get this EigenDA certificate back. And now, the decentralized sequencer is sequencing, and the L1 is the source of all truth here. And so we need to post that certificate to Ethereum so that we can sequence all of these different transaction bundles. And so again, this leader in this BFT consensus protocol can do this. And if they fail to do this, anyone can do this because EigenDA certificates are deterministic. You can get them from the EigenDA network. So any other validator can do that as well. Now, once it's on Ethereum and once it's finalized on Ethereum, then any full node in the L2 network can download the certificate and fetch the data corresponding to it from EigenDA. And then you end up getting what the decentralized sequencer placed into EigenDA, which is kind of the transaction bundle and the BLS multisig, as well as that bit vector. And so here, the key thing that you have to do is validate that this BLS multi-signature and bit vector is correct. And that's, I would say, an interesting point, because a lot of people, when they talk about decentralized sequencers, they talk about having a smart contract that verifies the correctness of the data and the fact that it was agreed upon by these decentralized sequencers. They talk about doing it in the smart contract level in Ethereum, but that's actually quite expensive, and it turns out it's actually not needed. If you have full nodes, simply do that verification at this step, then you don't have to pay kind of the extra gas costs to do it in Ethereum. And it has some implications for the bridge, but for the actual just core finality protocol for the L2, you don't need it at all. What's interesting is this isn't just trivially checking, oh, there's a permission set of decentralized sequencers. Did they correctly sign this? In Celo today and in this proposal, that set of sequencers can change at any point in time. And so you actually have to run, look at the current state of the chain to see who is currently elected, who is currently allowed to sequence these transactions, and then you verify that those signatures match. And so you can think of this as actually running something that looks like a light client protocol to verify that this is actually correct. And so once you do all this, then you actually can derive, the L2 block. And from then on, you have kind of an L2 block, and you can sync the chain. And this is, in effect, kind of the way that these nodes get the source of truth for what is happening in the network. Now, if you guys are familiar with kind of the inner workings of some of the existing L2s today, you'll know that this is a bit of a slow path, right? You have to wait for Ethereum, and sometimes it's nice to be able to sync more quickly. And so what many people are doing is gossiping blocks directly in a P2P network. OPStack calls these things unsafe blocks. And so these full nodes can get these unsafe blocks directly from the decentralized sequencer sooner. And that's nice. But it does present an issue, which is, what happens if these two things don't match? Right? That sequencer could have created one transaction bundle, and the whole decentralized sequencer could have agreed on it, and could have posted it to Ethereum, and then they could have created another one and then gossiped that. 2/3 would have had to have acted maliciously, but it is feasible, not unfeasible for that to happen. And so in that case, there's a solution. You might say, okay, well, this will just create a reorg, and we just always trust, what's happening in the L1. But that would mean that it could create a reorg, right? And we talked about the importance of one block finality. We really want a solution for this. And so the solution is one that we talked about before. If you ever discover that this is happening, well, it's actually really easy to tell that this happened, and it's really easy to attribute which of these decentralized sequencers contributed to this. Because we have that bit vector that shows exactly who signed and who equivocated. And so if the two things don't match, then you have all the evidence that you need to create a proof that a certain 2/3 majority of these sequencers needs to be slashed. And so this is how we kind of solve this issue. Yeah. And so maybe just to conclude around finality, with this type of slashing and with the changes that make it so that all transactions that are being kind of forced into the L2 from the L1 and all deposits, if those have to wait for finality on Ethereum, then you end up having a slower bridge, but you end up having much better UX for developers and for users. And it's true that right now this is secured, this one block finality is secured with the economic guarantees of the Celo network, and so all of the Celo stake that's put to use. But it really opens a door for us to extend this to offer additional economic security. And so EigenLayer allows you not just to have EigenDA as a middleware, you can have other middlewares. And so we've been chatting with the EigenLayer team about also having kind of finality gadget middlewares as well that can kind of really let the whole let you kind of tap into kind of all of that economic security of all of the EigenLayer validators who are opting into the service, and all of the incredible amount of stake that they have collectively. So that's really exciting, and what this ultimately means for developers and builders. Certainly better UX for end users. Certainly easier time for developers because you don't have to think about the UX in the case of a reorg. But also, it ends up making Celo a really nice place for L3s to roll up to, because you can just take an off-the-shelf L2 system, and it will just not reorg. And so then you just don't have to actually think about reorgs. And so that's really nice, and so it makes Celo kind of a really nice place, potentially for L3s. So yeah. I think that's the kind of everything I wanted to cover. This is the last emoji. I'm really excited for this. It seemed like the reception generally from the folks looking at the proposal online was also really positive. So we're really pumped. We're going to have a governance vote on it next week, and if it passes, yeah, expect to see Celo as an L2 coming to you soon. Thank you so much.
Any question? Okay, coming.
Thank you for the talk. So how does it compare to existing solutions, for example, Mantle, with using EigenDA or the technology similar to EigenDA?
Yeah, so Mantle is an L2 that is kind of, I think, working on also using EigenDA. Last I heard, they may end up actually using a fork of EigenDA and not EigenDA itself. And so it may end up looking a little different from this. But I think the main difference is the fact that we're working on that decentralized sequencer, and also all of the effort that we're putting into one block finality. So I would say those are the two big differences. I mean, I think also Celo is an established network. It's available on a whole bunch of exchanges and amazing custodians. It's being used actively in a lot of markets, especially in emerging markets for P2P payments. And so I think just from that perspective, it's just already very different.
Hey, thanks. I'm super excited about this. And my question is, when L2? So when is that going to materialize? What do you expect in terms of timeline?
Yeah, the most important question. First of all, we have to wait for the governance proposal. We have started some work on this, obviously even just coming up with this design and getting feedback and making sure that it's implementable easily was the first step, and we feel pretty good about that. But of course, we're still waiting for the governance vote. Once that lands, if it's positive, then we're going to be full steam ahead. We expect this to take 2 hard forks. I think it's it's a bit of an effort to turn L1 into an L2. It's it is something that's operating live. We don't want to just take it down. we can't take it down. I think that's going to take some effort. But the current plan is to have 2 hard forks, the first of which is already slated for August. And so that will happen soon. And then the second of which, it's really hard to estimate, but we're optimistically aiming for the end of the year, beginning of next year. And so hopefully we'll be able to hit that.
Thank you.
Thank you so much. I'll be outside if anybody has any questions.